I digress. I gotta get math in. Okay, on number 6 of the math workshop, what do I need to pull out? Okay, and if I pull out a 3PQ, what am I left with? 2, 3, and 4 can have a point. Perfect. If you forget to put your quiz back in the drawer, I will accidentally type in the 0. It's not accidental. I need my test back. So if you forget to give me back my quiz, I'm going to type in the 0, just FYI. On number 7, I know to combine the middle two, so it's x squared plus 6x plus 8. Now, how do I factor that? 1 gets the point. I know 4 plus 2 is 6. 4 times 2 is 8, so it ends up being an easy factor. Yay. Number 8 is also an easy factor. I need two things that add to negative 7 and multiply to positive 12. Well, tell me the signs. Say it again, Landon. Okay, so negative 3 and negative 4 add to negative 7. Negative 3 times negative 4 multiply to negative 12. So yes, Landon, you can have the point. Brady, are you going to handle number 9? Please do.
4 minus w squared, 4 plus w squared.
And he can have a point for that. However, we are not done, are we? Yes, dear. You can simplify this further because this is also a difference of perfect squares. So it should be... Okay, so 2, 4, and 5 can have another point. So yes, I broke down... Hold on, let me not under the screen well. I wasn't such a hurry. The 4 plus w squared we're just going to bring down. But I broke up the 4 minus w squared. It's 2 minus w, 2 plus w. It was still a difference of perfect squares. I should have realized this was going to happen. I understand you just took a test on perfect cubes and you just got those down. And no, I'm not saying there's 1 to the 4th anytime soon. But it just so happens 2 to the 4th is 16. So our problem was really 2 to the 4th minus w to the 4th. So I should have realized it was going to be an interesting one. Okay, number 10, I don't have a lot of room. I'm hoping she guesses correctly to begin with this guessing check. Yes, Drea. Okay, so she guessed. She realized 2n, so she did 2n times n to get 2n squared. She said, hey, that 9 on the end, I could do 9 and 1, or I could do 3 and 3. And then she guessed where the sign should be. So she may or may not be right. We will check by foiling it out. So first would be 2n squared plus 6n minus 3n minus 9. Lo and behold, we do get 2n squared plus 3n minus 9, so she is correct. That is the answer. Today is the day, ladies and gentlemen. If you've been bad at guess and check, I'm going to give you another option. But otherwise, if you got guess and check now, today is the day it's going to pay off. Guess and check, when we guess what the two factors are. Okay, we are on page 13 of your notes. Brady and I, at the beginning of class, were discussing his hatred of doing things solely in the calculator, which I understand. We can calculate all the things quadratic. We can calculate all the things quadratic using our calculator. But we can also calculate all the things quadratic by hand. Worksheet. Workshop, yes. Okay, so meaning. No, we're not doing that today. That's a good question. So far we've talked about, for instance, if Abigail wanted to do the axis of symmetry by hand, she knows it's negative b over 2a. She can plug that back in and get out the y coordinate of the vertex. She knows instantly when she sees the equation how to recognize the y-intercept. There are lots of things about quadratics that we can do by hand. In fact, we can do all the things by hand and never have to use our graphing calculator. Or we can solely rely on our graphing calculator. It's really your personal choice as to what kind of life you're going to lead. Except for this. So we talked yesterday, actually a couple days ago, about x-intercepts. So we can actually find the x-intercepts by factoring. So finally, factoring will be useful. We're going to use it to actually solve a problem. If we can factor, we can find the x-intercepts. So if we factoring get two answers, those two answers are our x-intercepts. Okay, we had two vocab terms that also meant x-intercepts. What were they?
Roots and zero.
Okay, well, I get the point. Knowing me, I'm going to use them interchangeably, so you've got to get used to it. I cannot promise I'll keep saying x-intercept. I'm probably going to start saying roots or zeros. Okay, since we're in a hurry, and we're specifically wanting to do the problems that are quadratics, we're only going to do the ones that are squared. So, for instance, 1, 3, 4, and 5 are out. 1 is grouping, 3 is to the 4th, 5 is to the 3rd, 4 is to the 3rd. So in the top section, we're only going to do number 2. I need help with number 2. Tell me when you have the answer and get you a point. I need help with number 2. When you got the answer, I'll give you a point. You can, but literally you can pull out a GCF and turn this into easy factoring. You do pull out a 3 and you're left with z squared plus 8z plus 15. That is correct. Keep going from there. How do I easy factor that?
Z plus 3 and z plus 5.
Okay, so we pulled out a 3 out of everyone. We're left with z squared plus 8z plus 15. I need two things that add to 15. Multiply to 15 and add to 8. 3 plus 5 is 8. 3 times 5 is 15. We're done. All it said was factor, and we have factored, so we are done. On the bottom 6 problems, it doesn't just say factor. It says solve by factoring. So we're going to have to do a little more. The first learning target for today is one you already knew. That's why there's so many today. It's one you knew already. The first one says we have to put it in standard form first. So if they're not in standard form, we will have to rearrange them. But otherwise, it's going to be a nice day. Okay, let's go to number 6. There is a GCF I can pull out. What is the GCF in here? Say it again. 5x. Table 5 can have a point. It's 5x, so we're left with 4x plus 3. And that equals 0. Okay, so yes, we factored, but we're not done because we haven't solved. When they have that equals 0, we actually know we're supposed to end up getting an answer, like x equals 2. Since it's to the second power, we can have up to 2 answers. In this case, we are going to have 2 answers. We're going to set each of those factors equal to 0. So I'm going to do 5x equal to 0 and 4x plus 3 equals 0. So my first root is 0. What is my second one? Over. Yes, Landon. Landon, I heard you first. You can have it. So it's negative 3 over 4. We solve the equation 4x plus 3 equals 0. We still get negative 3 over 4. And what this means graphing-wise is that at 0 and negative 3 over 4, our quadratic, our parabola, passes through that x-axis. Okay, number 7 is not in standard form. Can someone help me put it in standard form?
X squared minus 64.
Okay, table 2 get the point. So x squared minus 64 equals 0. It's a nice factor. What are my 2 answers? Say it again, Brady. I know those are my 2 factors, but what are my final answers? My solution. Yes, that's what I wanted. 3 can have a point. Okay, so yes, it's x minus 8 and x plus 8. And so I can set each of those equal to 0. So x minus 8 equals 0. So x equals positive 8. X plus 8 equals 0. So x equals negative 8. However, we could write that a little fancier How can we write this answer a little fancier? 3 gets another point. It sure would be fancier of us if we just said x equals plus or minus 8. You don't have to be fancy if you don't want to be fancy. Man, that looks like you understand math. You understood it was both the positive and negative versions, so you combine them. But again, all this means is that at both positive 8 and negative 8, our graph crossed the x-axis. And since I'm not taking the graphing calculator away from Landon, he could always check to make sure that it really is where the graph crossed. We're going to skip number 8 for the moment. Why am I skipping 8? Because it's got that 4 in front, it says a 1. Yes, 3. You get another point. Okay, so that's the problem. So we're going to skip number 8 for a second because it's hard factoring. You've rearranged number 9. What should it be? So it should be x squared minus 4x minus 21 equals 0. Perfect. You'll tell me the 2 factors. I'll give you a point. 3 is the point. Negative 7 times 3 is negative 21. Negative 7 plus 3 is negative 4. So what are my 2 answers? Three gets another point. Okay. If you're like Brady, and you've realized at this point that the answers end up being the opposite side, like instead of minus 7, the answer is positive 7. Instead of positive 3, the answer is negative 3. If you connected those dots, you don't have to do the last 2 steps down here at the bottom, because you got it. But if you want to show it, you can. It doesn't hurt my feelings if you're doing some things in your head. Okay, number 11 is on you. Tell me the answers. There is a GCF first, so it is an easy factor. Number 11. It's, what are my 2 answers? Say it again, Travis. I understand. What are my 2? I just want the answers. Go straight to the answers. So, like, x equals what and x equals what?
X minus 4 equals 0 and x minus 2.
But I still just want the numbers. X equals what and x equals what?
Negative, yeah.
Negative 2. Okay. It's 2, 3, and 5 can have the point. Okay. Yes, I end up pulling out my 2. So I have x squared minus 6x plus 8. I agree. Negative 4 minus negative 4 and negative 2 give you negative 6. Negative 4 times negative 2 gives you positive 8. And then you end up doing x minus 4 equals 0 and you get 4. And x minus 2 equals 0 and you get 2. The good question to ask me would be, where on earth did 2 go on the outside? And I understand. In my mind, I've divided by 2 on both sides. And I know 0 divided by 2 is 0. So that's why it's only x minus 4 equal to 0 and x minus 2 equals 0. The 2 ends up going away because when we divide both sides by 2, 0 divided by 2 is 0. So if there's any constants on the outside, they're going to end up going away. Because when you divide both sides, 0 divided by a constant is 0. Okay, our last 2 problems on this part, well, it's not all we're doing today, but our last 2 problems on this part are not fun factors. I'm going to go ahead and rearrange number 10 and make it 15x squared minus 8x plus 1 equals 0. Okay, since we're on number 10, we've already rearranged it. Let's go ahead and do it. I'm going to do guess and check, and then I'm going to show you another method. So if we guess and check, do we want to do 15 and 1 or 3 and 15? I mean 3 and 5. 3 and 5, they said. And literally we're guessing. So if we're wrong, we might change it to 15 and 1. Okay, I need it to multiply to positive 1. So am I going to do positive 1 and positive 1 or negative 1 and negative 1? They both need to be negative because I need a middle negative. So let's see if this is right. We guessed. Now we're going to check it by foiling. First would be 15x squared. Outer would be negative 3x. Inner is negative 5x. Last is positive 1. And we have, when we combine those middle, we would get negative 8x. So we have guessed correctly. So we have factored correctly. I'm still going to need the two answers. What are my two answers? Yes. Corbin, you said it first. You can have it. DJ, you were very close. Okay, so literally all that means is that wherever 1/3 happens at, like 0.3, and then 1/5 is like 0.20, those two spots are where my graph is crossing the x-axis. If you are hating guess and check, you do not like it, there is another method I can show you. If you do not like the method I show you, come to 0 period. I got at least 2 more options to try to help you with factoring. I understand when it doesn't have a leading coefficient of 1, it can be a pain in the rear. Okay, so the method I'm going to show you is called slide, divide, bottoms up. So here was our problem. The first step in this method is called slide, meaning we take the number in front and we end up multiplying it with the last to turn it into an easy factor. So we slide it to the end. So it's x squared minus 8x. 1 times 15 is 15. So for the slide, we slide the 15 down and multiply it with that last term. Our next step is divide. Really, it's just easy factoring. I need two things that add to negative 8 and multiply to 15. So I say, 3 and 5. Negative 3, negative 5, negative 8. Negative 3 times negative 5 is positive 15. So I've done my divide. Say it. Ask it.
I said, where'd the 1 go?
I slid the 15 down, and then 1 times 15, you got 15. That's what the slide means. I'm not saying this is the best method. I'm just saying it works. And then divide means I get to do easy factoring. That's why some people like this way, because you get to do the easy factoring. And then here's the part. The reason I don't do this method is because I always forget to do bottoms up. So I'm so excited I think this is my answer. So I say the answer is 3 and 5. And you and I both know the answer was 1/3 and 1/5. So I would be wrong if I don't do the bottoms up. So the bottoms up is when we take our two factors. So we had a 3 and we had a 5. And we end up putting them over what we slid down. We slid down to 15. And then you're like, Miss Compton, that fraction reduces. You're right, let's reduce it. So that's 1/5. And this one is 1/3. So I could from here say, oh, my answer is 1/3, 1/5. But if you want to know how we got the factors we got earlier, they don't leave them with fractions. They end up putting that 5 in the front. So it's 5x minus 1. And they move that 3 to the front. So it's 3x minus 1. And if you look back at your notes, the two factors you and I just got with guess and check were 5x minus 1, 3x minus 1. If you like this way better, do this way. I'm giving you some options. If you didn't like this, and you didn't like guess and check, then I got some more ways. Come see me 0 period. I like guess and check. Not that big of a deal to me. But if you do not like it, do this. This works. Yes, dear. You can have it. Come here. Here's the 2 from last period. Oh, yeah, you can have this one. Come here. Here's my last one. Will, could you ask for those? Or Mason?
I'll take one.
Here, take these 2. Okay, so in our next problem, our last one, I'm going to do guess and check first, but then I'll show you slide, divide, bottoms up. Okay, so guess and check. I got to deal with the 4. So I can either do 4 and 1 or 2 and 2. Which one do you want to do? 4 and 1 or 2 and 2? We're guessing. We're going to guess 2 and 2. If we're wrong, then we might come back and do 4 and 1. Okay, I need them to multiply to positive 9. So I can do 1 and 9 or 3 and 3. Which one do you want to do?
3.
Okay, and then should it be a positive 3s or negative 3s? Or they both need to be negative in order to get that positive 9 at the end and a negative term in the middle. So we've guessed this. Let's check it by foiling. First would be 4x squared. Outer, negative 6x. Inner, negative 6x. Last, positive 9. Lo and behold, we do get that negative 12. So we guessed correctly. You guessed correctly a lot. You're pretty smart. And then when you don't guess correctly, it's not a big deal. Instead of 3 and 3, do 1 and 9. Or instead of 2 and 2, do 4 and 1. Okay, but I still need my 2 answers. So what are my 2 answers? Two-thirds. 3 halves. It's 3 over 2.
Captain,
Yes, ma'am.
would you let Landon Samuels know we have something in the main office to pick up, please?
Yes, ma'am. Okay, so we got 3 halves twice. So we really didn't have to write it both times. And what that means graph-wise is what?
Oh, it only has 1 grid.
And be very specific. So what does that mean that one spot is? So it only crossed it once at 3 halves, and that one spot has to be the vertex. So gets the point. Someone said that last period, and I hadn't even really thought that through, and that's genius. So yes, it was 3 halves twice. So what was I gonna do? I super bore down on that point? Like, I don't know what you want me to do. It only hits that one spot. Which means it has to be the vertex. Okay, but if you're still mad at how we did that guessing check, I'm still going to do this problem with slide, divide, bottoms up. So it was 4x squared minus 12x plus 9 equals to 0. This pen does not show well. Let's do a different pen. If we slide x plus 36, because 4 times 9 is 36. And then with divide, it's now easy factoring. Yes, because negative 6 and negative 6 is negative 12. Negative 6 times negative 6 is positive 36. This is completely right. Okay, now I've got to do my bottoms up. This is where Miss Compton ends up getting in trouble, hence why Miss Compton has to do guess check. So I know it's x minus 6. What do we slide down? Okay, but I can reduce those fractions to what and what. And notice our final answer was 3 over 2. So if you've gotten to this point, you already know the answer is 3 over 2. But we still got to do, we're not quite done doing bottoms up. We move the 2 in front. We'll have 2x minus 3, 2x minus 3. Lo and behold, that's exactly what we had when we did guess and check. Yay. So pick one, roll with it, but you got to pick one. Because you realize if the problem says solve by factoring, you have to solve by factoring. Now, Drea can check on her calculator to make sure it really did just hit 3 halves, and that's where that vertex is. No one's taking the calculator away from you. But if it says solve by factoring and Drea has no work on factoring, then how did I know she factored? Yes, dear. Yes, dear. Travis, is that what you wanted? Y'all know you can watch all this again. I put it on YouTube for forever. Okay. And this is great. But, you know, let's look at our graphs. We've talked about when we factor what it would look like to cross the x-axis once. We talked about what it would look like to cross it twice. What are we going to do if we can't factor it because it never crossed the x-axis at all? What are we going to do? And that leads us to our next page. So flip to the next page. Yeah, I'm talking the whole time today. You want me to keep talking or else that means you have even more to watch tomorrow. What happened is, there's this potential of what if we don't ever cross the x-axis? What are we going to do then? And the answer is we're going to use the quadratic formula. That's next week's problem. After this next test, we'll get to the quadratic formula. So if you're a bad memorizer, you might want to look that bad boy up and go ahead and start because you need to know it. But the quadratic formula, no, the negative b plus or minus, yes. Okay, but the quadratic formula requires you to know something you didn't know yet, so that's what leads to the next section. When you're on my nerves, take a point away.
Oh my gosh.
Okay. In order to do the quadratic formula, in order to deal with problems that aren't factorable, so like a problem that never crosses the x-axis, we're going to have to know about imaginary numbers. So at the beginning of the year, we talked about real numbers, integers, natural, that kind of thing. And that was a lot of fun. So much fun. I'm sure you remember it all. I know I do. But we never actually talked about imaginary numbers. Imaginary numbers kind of happened the way pi happened. They kept noticing 3.14 or 22/7 kept happening. So eventually they came up for a symbol to represent it. In the same way, a Greek mathematician kept noticing an issue happen. So they came up with a letter to represent this issue. Okay, we know the square root of 25 is 5. We know that. The issue is when it's the square root of negative 25. You can't have a negative under the radical. That's what you've been told your whole life. You can't do it, you can't do it, and this is where you normally quit. Well, they got tired of quitting because there needs to be an answer. So what they realized is that it's really negative 1 times 25, and they broke those up and said it's square root of negative 1 times the square root of 25. Well, I know the square root of 25. I'm going to write it up, sorry. It's 5. What I don't know is the square root of negative 1. And it is, it's I. So we started using a symbol for it. So our answer is literally 5i. So anytime you see the square root of negative 1, you replace it with the letter I. Notice that when I write my I give it kind of a curl. That's intentional. That's how they do the imaginary I. They don't do it straight up and down. It needs to have a little bit of a curl to it. Okay, so if you're looking at your notes, the second sentence says the number I is the square root of negative 1. That is, I is the square root of negative 1. Negative 1. So I literally is the square root of negative 1. And it stands for this imaginary number, which is the square root of negative 1. Okay, so how we're going to deal with it, let's do 1, 2, and 3, and then we'll come back to that. Okay, so number 1, I can think of it in the same way. It's really 121 times negative 1. So it's really square root of 121 times square root of negative 1. It's really 11i. So, yay, now that you're getting the pattern, let's go ahead and do 2 and 3, and we won't even show work. What is the answer on number 2? Drea said it first. She gets the point. What's the answer on number 3? Oh, God, Drea gets the other point. She's fast on her perfect squares, man. So if it's a perfect square and there's a negative with it, it ends up being your number with I. No big deal. I is so nice, we can actually do more than that with it. We can do some math with it. Like, for instance, number 4. Instead of doing square root of negative 2, I can do square root of 2i. Because isn't it square root of 2 times square root of negative 1 anyway? So why can't I write it as square root of 2i? How could I rewrite square root of negative 32? What would it be? Yes. Okay, so 2 can have a point. I think 5 can too. So literally, we've just gotten rid of the negative signs by putting I out front. And now I can multiply like normal. I'm going to multiply the 2 numbers under the radical. I'll get square root of 64. And I'll get square root of 64i squared because I times I really is I squared the way x times x was x squared. Yes. I know you know the square root of 64. Yes, there is a nice answer to this, but that requires a little break in our normally scheduled programming. You probably want to write a little chart either at the top or to the side somewhere. There are 4 powers of I you need to know. You need to know I to the first. You need to know I squared. You need to know I to the third. you need to know I to the 4th. From this day forward, you need to know those. If you don't memorize I cubed, it won't kill you. But heck, if you're already memorizing I squared I to the 4th, why not I to the 3rd? Tell me. I know you're excited about it. I'm excited about it too. Tell me.
1.
Yeah, I to the 4th is 1. Okay, and then I squared is, y'all know that one? It's negative 1. Okay, so let's talk about this. I is the square root of negative 1. So I squared is square root of negative 1 times the square root of negative 1. It ends up being negative 1. I to the 3rd ends up being negative square root of 1. So it ends up being negative I. It's a terrible pain in the rear. I understand why people hate I to the 3rd. But I to the 4th is the best thing that ever happened. Because it's I squared times I squared. And we just said I squared was negative 1. So it's negative 1 times negative 1. So it's freaking positive 1. It's amazing. So seriously, what you need to learn, and Miss Brewster taught me this morning. Don't think I've known this forever. I haven't. It's I, negative 1, I, negative I, positive 1. So if you're trying to memorize it, it's I1, I1. I1, I1. I had never thought about it like that till this morning. So if you're struggling with it, it's I1, I1. Okay, so back to our problem. We had square root of 64I squared. I know the square root of 64. What's the square root of 64? 3 gets the point. They were first. But I know I squared. What's I squared? So my final answer is, and it's amazing. Like, I don't know. I can't brag on it enough. It's the coolest thing that ever happened since sliced bread. Okay, so now we've got to do number 5. We've got square root of negative 75. So I'm going to say that's really what? I'm really going to say that's 75I. I don't know why I gave it such a big radical, but I did. So that's 75I. And how am I going to rewrite the square root of negative 3? Yes. So I'm going to do square root of 3I. Okay. If you realize it simplified before, go ahead and simplify and do the things. You can. We're going to keep going, and people maybe didn't realize the 75 could break down. That was smart. You can have a point for that 5. Okay, what's 75 times 3? So I actually have square root of 225 I squared. What's 225? Square root of 225? 115. It's just 15, right? So I've got 15I squared, but I squared is, so my answer is really what? Okay, so can you take a guess at what the answer is on number 6 then? Okay, but tell me the final answer. Thank you, 5 and 4. 5 and 4 can add the point. So yes, it's 24I squared, but I know that's negative 1. So it's 24 times negative 1, which is negative 24. And if you're understanding this pattern, do you have to show all this work? Heck no. You can just put the answer. That's fine with me. Does the work help if you make a mistake? Absolutely. But I understand you're excited about life. Travis, I know you're excited. Tell me number 7. What? Is negative or positive?
21.
You say positive 21, you say positive 21.
It's 21.
Yeah, normally your man is right. So it's negative 21 times negative 1 is positive 21.
Yeah.
Agreed. Okay, and then this is where life gets so much fun. I to the 4th is what?
1.
So number 8 is 1. And then we get to number 9, and you're like, Miss Compton, you didn't tell me I had to memorize I to the 11th. You just said 1 through 4.
This is subtracting by 4.
Yes, so somebody who knows, who's done this before. So I don't know how y'all are so, well, I do know how y'all are so good at Corbin and DJ have not, this is not their first rodeo. We love out of the 4th, right? It's just 1. So wouldn't it be cool if we could make this in terms of 4? So what if we wrote this as, I know it's a strange thought, but maybe like I to the 4th, I to the 4th, I to the 3rd. Because 4, 8, 11. That'd be one way to do it. I know I to the 4th, that's 1. I know I to the 4th, that's 1. What's I to the 3rd? So what's my final answer? So it's just, and I'm not going to put one negative I because we're in math class. We're just going to put negative I. Okay, in my head, I don't even think it through like that. I know this is sad, but I think through I to the 8th would be a nice one because it's a power of 4. And then I'm saying, oh, 8, 9, 10, 11. I know it's I to the 3rd, so therefore it's negative I. So let me say that again. I think through, I love powers of 4, so I go to I to the 8th. And then I think 9, 10, 11, I know it's I to the 3rd. So on number 10, I go to what number? On number 10, I already know the answer. It's what? So what's a power of 4 that's really close to 25? 16, there's higher. There's higher. 24. So 24 plus 1, right? Would be I to the 25th. So it's just I. Your calculator cannot handle complex numbers. I hate to break your heart. It is not very good at complex. Well, I'm not even going to insult the calculator. You know I love it, but do not think this can do this one for you. Okay, goodbye. I'll see you tomorrow. I don't know about tomorrow. I'm posting a video if I don't see you. We got to finish the complex numbers. I'm sorry. Bye. Sorry, bye. That's how I